I appreciate you stopping by to check out yet another episode of Vintage Audio Review. And the subject of this episode is, you guessed it, this McIntosh MX117 AM FM stereo tuner preamplifier. This was sold between 1980 to 1984, and if you had the equivalent of $5,350 of today's money, today being November 2023, you could purchase this gem. I'm going to cover some of its features in the front and kind of show how the tuner works. We'll look around back, see what's back there. I'll take the top off, we can kind of peer and see what's going on there, and then there'll be measurements, and finally I'll give you my thoughts after listening to this guy. Here is a more intimate view of the MX117. I'm going to go ahead and turn it on by pressing this red button. I like the way that McIntosh makes it easy to figure out which is your power on-off button. Over here on the left side is our input selector. We have inputs for auxiliary, then the AM, FM, and it has an FM mute, position 2 on the tuner, as well as your two phono inputs, phono 1 and phono 2. Now, I'm going to go ahead and show you how it tunes a little bit, and we'll go over to the FM, just normal FM, and what'll happen is if you get close to the station, the little plus LED or the minus LED will come on. Right now it's on the plus LED, so I'm going to go ahead and tune it, and when that center bar goes up, that means you're perfectly tuned. You can also see there's an FM stereo indicator LED there, and this is a strong signal, so this tuner does a really good job. You can kind of see the action. It's on the plus side, now it's on the minus side a little bit, and now it's perfectly tuned, and that's the way that the FM tuner works. So if you have it on the FM mute position, then it will mute the static while you're tuning the station. If you go to the AM mode, all you get is a signal strength LED, so the LEDs that are up just tell you that your signal is strong or not, so that's kind of an indication on how that works. If we come over here, these buttons here are for your tape 1 or 2 and your dubbing configuration that you want. Here's a 1/4 inch headphone jack. You have a 3-band equalizer, 30 Hertz, 750 Hertz, and 10 kilohertz. This guy right here is our loudness control, the one in the center. The balance control is on the outside. These are all center detented, so when you get to the center spot, they're detented where they would have 0 effect, and your balance also has a center detent. Now your volume control is fully detented. Let's see if you can hear it. And as you'll see from the test data, the channel balance is very good. Obviously this is our tuning indicator here. Now this guy right here and this guy right here are the buttons that you would press for the pan lock system. If you had a case and you mounted this in the case, you could remove this using the pan lock, assuming it's a McIntosh case. So that's kind of the front of the unit, and now we're going to go look at the back. This obviously is the rear of the MX117, and starting in the upper left corner we have our wire inputs for the AM and FM antennas. We have a coaxial input for the FM antenna, and we have an FM preselector switch there. And what that would do is if you are located near a very strong FM transmitter, you could put that to the in position and it would offer some attenuation at the front end of the FM tuner. You have 3 switched outlets here and 2 unswitched outlets. It's kind of neat how they color code them. You have a user replaceable slow blow fuse. You have our AM antenna rod right here. You also have outputs for a scope. So McIntosh sold a small little oscilloscope that was designed to take these outputs, and it would show you a display for tuning more accurately. You could also connect those to a normal scope if you had one, and use it to get a better tuning indication, as if the LEDs up front aren't good enough, you could do one step better by using that. You also have two sets of main outputs right here and right here, and then you have a line level output. And really the two main outputs are exactly the same. The line level output is designed to be put into a 600 ohm load, I believe, is maybe a better matching, but it goes, all the signal, the volume control changes and the tone control changes go through the line output as well. We have our two tape outputs right here, tape 1 and tape 2, and then you have inputs on this side. You have the input for your phono 1, phono 2, auxiliary, and then your tape 1 and tape 2 inputs. Then you have your ground lug for your phono there, and this little guy and this little guy are part of that pan-lock system. So here is a quick inside view of the MX117. You can see just kind of the technology that was used and how it kind of was put together. Everything is labeled nicely, it seems, at least relating to the tuner section. We have a transformer, I guess, would be inside this guy, and here would be our power supply, and I don't know, this would be input select coming in here, and I don't know if we can see it real easily, but there's a circuit board. Yeah, you can kind of see it down here on the bottom, as well as another circuit board down there. And it's kind of just an idea. Here's the tuner LED board, is this guy right here, and it's just kind of how it's put together. Very nice and organized, it would appear to me. One thing I like about several of the McIntosh products that I've tested is that they have their specifications right on them on the top. This tells you the performance of the preamp section as well as the AM and FM tuning sections. And their stuff like signal to noise ratio, that kind of thing. Unlike another company whose initials are ML that wouldn't tell what their specifications were for their preamplifier other than how much power it used and how much it weighed in its dimensions. So McIntosh is pretty happy to put their specifications on their product. Here's our standard THD SNR plot at 1 kHz with 2 volts going in and 2 volts going out. I've adjusted the volume control to give about 0 dB of gain, and you can see that we've got 2 volts out and 2 volts in. So it looks pretty good. The SNRs are above 90 dB, and the THD is better than 0.003%, we'll say. The specification is that the THD from 20 hertz to 20 kilohertz should be less than 0.02%, and it most definitely is by about a factor of 10. Right now we're looking at the frequency response of the auxiliary input to the main output from 20 hertz to 20 kilohertz with a 6 dBV signal applied, and the volume control gain is set to about 0 dB gain. Actually, it's about half a dB, but because the volume control has little steps, you can't get exactly 0 dB gain, so half a dB lower than that is pretty close. There is a specification that the frequency response should be +0 to -0.5 dB across that frequency range, and we are definitely meeting that. We're basically, maybe I'll call it plus or minus 0.2 dB across the band. The channels are balanced to within 0.2 dB, and if I were to decrease the gain of the right channel, I could probably bring that down a little bit, but I'm not going to worry about them not being balanced better than 0.2 dB. I should also point out that the loudness control is set full counterclockwise, and I'll show you what happens as that loudness control is adjusted. Also, I should point out that the little 3-band equalizer, our 30, 750, and 10 kilohertz knobs are all set to midpoint, so they are out of the circuit, and they do look like they are out of the circuit. But I'm going to go ahead and adjust the loudness control a little bit. Okay, so I tweaked the loudness control just a little bit. I didn't play with the volume control. I just tweaked the loudness control, and it's about maybe a third of the way from full counterclockwise. And you can see that
it boosted the lows up quite a bit by maybe 4 dB, and then the highs and mid-range it kind of boosts a little bit. Now it would be in reference to 0 here, so maybe the high end it tapered off a little bit, but it did boost maybe the mid-range a little bit up to about 10 kilohertz, and then it kind of tailed off. So that's kind of what the effect of that loudness control does. It's a variable loudness similar to the Sherwood. Sherwood has a similar kind of a feature. And Yamaha has something that they would like to do this, but I've never been able to get the loudness contour control on the Yamahas to do anything other than just attenuate the heck out of the signal. So anyway, this is what the McIntosh one does. And if I were to adjust the volume level, it would affect the amount of gain that this thing showed. So just for grins, I'm going to decrease the volume a little bit. So I did decrease the volume a bit, and it really didn't affect the levels at all. From what I can tell, they seem to be about the same. So unlike the Sherwood contour loudness control that they have, this one on the MX117 doesn't seem to be affected by how much or how little you change the volume control setting. Here is the THD SNR plot at 1 kilohertz, and it's almost the same as the one that I just showed you, except in this case I have adjusted the output level so that it has 2.5 volts going out, and we're still at unity gain, so we got about 2.5 volts going in. And the reason that I did that is because the specification is actually the distortion. The specification for the MX117 is that actually with a 2 volt output, it should have less than 0.02% THD. And we are definitely meeting that as we were before. So it looks really good with a 2.5 volt output level. So right now we're looking at the THD SNR at 1 kilohertz with a 6.5 dBV signal going to the auxiliary input. And we're looking at this at the main output. And what I want to do is increase the volume level until we start getting a lot of distortion to see how much voltage we can actually get out of this guy. And right now we have about 10 dB of gain with the volume control, and I'm going to bring that up a little bit more. And so it's still looking not bad at 12.6 dB or so gain, and our voltage out is about 9 volts out RMS. I think we can go up at least one more notch, and now we're starting to see an increase in distortion. You can see it over here. The readings are still pretty good, and the SNR is pretty good. THD plus noise is not great, but not bad. And we're at about 10 volts out, and our gain's 13.5 dB, so maybe we could go up one more volume detent, and that looks like we hit a lot of distortion there, so I'm going to back it down a little bit. So you could probably get safely about 10 volts out of this guy with reasonable numbers. You'd still be meeting the specification, at least on the left channel, of better than 0.02%, and 0.04% isn't too far off. So the MX117 could definitely put out between 9 and 10 volts if it needed to. This plot shows the THD versus frequency for several different output levels, and we are going from 20 hertz to 20 kilohertz. The specification is that it should be less than 0.02%, which it is across this band. The key is this 5.9 would be about 5.9 dBV in, which is right at 2 volts in, and the minus 6.1 would be about half a volt input. So this kind of just shows you how it performs at different input signal levels to the auxiliary 1 input in this case. Here is the MX117's multi-tone response, and this is from the auxiliary input to the main output with a 0 dBV or 1 volt signal applied. And depending on where you read it, if you use minus 80 as some of the points are up near that to maybe minus 100, you're looking at between 13 to maybe 17 bits of distortion-free range. Here's a plot showing the crosstalk, and this would be for the auxiliary in to the preamp main output. And there was no specification for it, but it's anywhere from 75 dB to 53 dB, so it's not bad. Right at a kilohertz, it's above 70 dB, so that is fairly decent. Right now, we're looking at the system noise of the MX117. In this case, I have selected the auxiliary input and terminated those inputs into shorts. And what we're seeing is the overall noise of the unit. And there is a specification for a signal-to-noise ratio for the auxiliary input. And with an unweighted situation, which is what we have here, we should be about minus 90 dB down, and we're about minus 85 dB down. We have this 60 hertz hum bar coming through. And if I go ahead and turn on the A weighting, we should be down at least 100 dB, and we are indeed down 100 dB. So right now we're looking at the THD SNR plot at 1 kilohertz of the phono 1 input to the line 1 output, and I've got a 2.23 millivolt signal going in, and the reason for that is there is a specification for phono 1 and phono 2 inputs that with a 2.2 millivolt in, you should get 1.25 volt out, or 55 dB of gain at 1 kilohertz. So look at that. We're at almost 55 dB of gain, depending on the channel, 54 to 55, let's say. Distortion is less than 0.002%. SNRs are above 62 dB. And this is for that's a small level signal. I usually use 5 millivolts going in, and we've got 1.18, 1.22 volts. So pretty close to the 1.25 volts that it's supposed to have according to McIntosh, so that's pretty impressive. Now, I do not have the RIAA weighting on. If I go ahead and turn that on, it's going to flatten out this noise here. Let me go ahead and do that. So I've applied the RIAA weighting, and it kind of flattened that out. It doesn't really change a lot up here very much. Maybe the signal-to-noise ratio, I guess, got a little bit better. So it changed that, but this is what it looks like with the RIAA weighting applied. So right now we're looking at the THD SNR response of the phono 1 input with a 5 millivolt signal applied, which is the normal signal level that I use for the phono test. And it's looking really good. That distortion is real good. The SNRs are almost 70 dB. I should point out that the output is measured at the line 1 output, and the volume control is adjusted to give me 40 dB of gain. So it actually looks really good here. I'm going to go ahead and turn on the RIAA weighting, and you'll see this curve kind of smooth out the noise curve. So it actually improves the SNR a bit when you do that. So anyway, so that's kind of what it looks like with the RIAA weighting applied and the gain set for 40 dB. Here is the frequency response from 20 hertz to 20 kilohertz of the phono 1 input with a 46 dBV signal, or 5 millivolt signal going in, and the gain of the volume control has set to give about 40 dB. There isn't really a specification for the frequency response other than the overall unit frequency response, which was about plus or minus half a dB. The low end of the band here for the left channel, it's down maybe, we'll just call it half a dB, and at the high end of the band, maybe we'll just say 0.4 of a dB, worst case. And the channels are balanced to within, I would say 0.3 of a dB, maybe a little bit more than that. That could be adjusted by using the balance control, but even then, the worst case on the right channel would be that it was up maybe 0.4 dB, and it also would be down about 0.4 of a dB at the high end of the band, and not down as low, maybe 0.3 of a dB at the low end of the band. So overall, this is a pretty good looking phono stage.
As the test data showed, this particular McIntosh MX117 did an outstanding job of meeting its specifications from about 40 years ago. It performed really well, and it's easy to use. I think it has a lot of features. I really like the looks of it. I just like kind of the got McIntosh look, more of the vintage McIntosh look, but I think it's a nice look. It fits well with its size and weight. I just think it's a great component for somebody to have. If you can find one and can afford to pay the price. The last I saw, they're about $1,400 to $1,500 on eBay plus shipping. Ones that are working, I don't know if they've been gone through, but you may not have to go through them at all. As far as using this guy, I hooked it up to my Wilson Watt 3 Puppy loudspeakers through the Bryson 2B LP amplifier. It did sound just fine. It sounds really good, actually. I mean, I didn't A/B it with another preamp, but it didn't lack anything other than the obvious having a remote control or another auxiliary input. And there's a video where I show you can add a remote control to something like this if you wanted, and it's not that difficult to do. As far as if you wanted more auxiliaries, you'd have to get an auxiliary switcher to add a separate one, but for most people, one auxiliary input is going to be fine. I don't know what the thinking was back in the day to have two phono inputs. I didn't know anybody that had two phonographs other than a couple guys that DJ'd and like me, and I had two turntables, but I had a mixer preamp that I used, so I wouldn't have had a need for something like this. But I've never really figured out why people had the desire to have two different photographs. But if you know, you can tell me, because there are several receivers and integrated amps and tuner preamps that did have two phono inputs. So hopefully you can shed some light into that. And as far as like turn on, turn off thumps, there may have been just a small little, like a little click that you hear, a little small little pop, very, very minor. And on the shut off, there was no unusual sounds. It's quiet and it's just a joy to use. I like having the three equalizer controls, and I did use the variable loudness control, and I like the way that used to dial in the bass. So this preamp, as far as sonic qualities, to me didn't add or subtract anything. It just sounds really good. It would be a pleasure to have. It could be your main preamp as far as that goes. As far as the scratchiness of any of the controls or switches, I didn't really notice any. It's possible that maybe they have been cleaned at some point, but as far as its operation, everything worked on this particular unit. I understand why people are fanboys of McIntosh. I'm certainly now a fanboy of McIntosh. The stuff I measured so far has been really, really good, with the exception of the tube preamp, which I thought lacked a bit, but you have to look at that video. But as far as the sound of it, it sounded just fine. They're not afraid to put their specs on the top of the unit like you saw earlier, unlike Levinson doesn't even tell you the specifications in their preamplifier, at least the one preamplifier that I reviewed a while back. So be that as it may, I thank you for watching the video. If you like the video, give it a thumbs up. That always helps a little bit for YouTube's algorithm stuff. And if you have any questions or comments, leave them in the description and I will attempt to answer them. And if you have not subscribed, please do so, as that helps the channel grow. And until next time, have a great day or night.